Hello, dear students. This is a discussion on the exam coverage document for Physics Inspire Series Grade 10 Advanced. In this exam coverage, we have very few chapters to study, right? So it's a short chapter, unlike grade 9, grade 10 is easier. So, inshallah, I hope you will do well in this final term. So, let us, without much further ado, let's go to the exam coverage points, the learning outcomes. So, this is the first learning outcome. In this, you can see it's explain how the relative motion between a conductor, such as a wire and a magnetic field, causes an induced EMF. So basically, you know that whenever there is a conductor, if it passes through a magnetic field, if there is a relative motion between the conductor and a magnetic field, it will produce induced EMF. So that's Faraday's law of electromagnetic induction. So in this law, they can have a multiple choice question, and they can also ask you in what direction is the induced current flowing. So for that, you have to use the Fleming's right hand rule. So that is the first. This is the first learning objective. Now let us go to the second learning objective. In this, what you see is this is like define electromotive force (EMF) and specify its unit as a as volts. So remember, electromotive force is not a force. It is only called a force. It is called electromotive force, but it is not a force. It is the potential difference or the voltage which is induced whenever a conductor is moving through a magnetic field. So they could ask you what is the unit for electromotive force or what is electromotive force, and they can give you a set of units, and they can ask you to select the correct option, or they could ask you to define electromotive force, which is the force, which is the potential difference which drives the electron or the charged particle between positive and negative terminal in a battery, in a cell, or in a generator. So that's the second objective. Now let us look at the third one. So here they could give you a multiple select question, like identify devices and machines that operate primarily on the principle of electromagnetic induction. So remember, electromagnetic induction is used in several devices and machine. One is the generator, the dynamo. It is also used in things like the what is called uh, the microphone. So microphone uses principle of electromagnetic induction, and even things like braking. Braking is used. It uses electromagnetic induction to produce eddy currents. So electromagnetic braking is used in cars and vehicles. So these are some of the devices and machines that operate using electromagnetic induction. Then you have what is called the identify the phenomena associated with electromagnetic induction, which fulfills Lenz's law and confirm that there is no ideal physical quantity. So basically, we have to identify a phenomena which fulfills Lenz's law and confirms that there is no ideal physical quantity. So, what does it say? Like you can be given a situation, maybe a picture or some set of pictures, in which you have to identify how the Lenz law is applied. So that is what we can make of this question. Then you have describe the Lenz law as a consequence of law of conservation of energy. So Lenz law is a consequence, it's a result of law of conservation of energy. Energy cannot be created or destroyed. So that is what is going to be tested in this question. So the thing is, it's like whenever you take a coil and push a bar magnet through the center of the coil, if it will try to repel if you're trying to make it go into the center of the coil, it will repel it, and when you try to pull it apart, it will try to pull it back. So basically, you have to put effort to move the magnet through the coil, in and out. So that's what is called the law of conservation of energy is applied there. So that's how the Lenz law is applied in that. Then you can have another question wherein the effective current and electric effective potential difference to their maximum values in the AC circuit. So calculate the maximum and effective values of current, voltage, power, and power for an AC generator. So here you will use the direct formula which connects the effective voltage or potential, current or power to the maximum voltage, current or power. So so there is a direct formula. So you will be given the formula in the exam paper. So you can use those formula to calculate that. Then you have to use the seventh question, which uses how to calculate the induced EMF. So EMF is equal to BLV sine theta. So theta is the angle between the magnetic field and the length of the wire, and between the magnetic field and the length of the wire and the velocity. So so that's what we will be using in this. So it's a direct application of the equation. So theta is the angle between B and V. Okay, then you have calculate the speed of electromagnetic waves in different mediums of different dielectric constants. So there is a formula for which relates the speed of the electromagnetic wave to the dielectric constant, which is V is the velocity of V is equal to C over square root of K. K is the dielectric constant. V is the speed of light in a medium like glass or water, and C is the speed of light in vacuum, and K is the dielectric constant. So you have to rearrange the equation and try to find out what is the dielectric constant. Now dielectric constant has one more formula, which is dielectric constant is equal to n square, which is the square of the refractive index. So this is another question. Then you have what is called in the question 9, you have to use the wave equation to calculate wavelength, frequency, or speed of the electromagnetic wave. So this is a very straightforward question. V, the speed of the waves, electromagnetic wave or light, V is equal to C times lambda. C is the speed of light and lambda is the uh, s- uh, f times lambda. C is equal to f times lambda. C is the speed of light, f is the frequency, and lambda is the wavelength. So you have to put in the two of the values in and find the third unknown value. Then you have the next one is 10. And the 10th learning objective, you have determined the optimal length or orientation of an antenna for the best reception of a given wave. So you will be given a length, and you have to find what is the best length which can and in what direction the antenna should be pointed in order to get the best signal reception. So this is part of the section in the textbook which is called receiving electromagnetic waves. So you will find the information there. Then you have question number 11, which is about transformers and how they are used in the national grid to minimize power losses. So basically, transformers are in a power grid, like power grid where the power is generated, electrical power is generated. The electric power, when it is generated, it is generated at a very high voltage, and then it is transmitted to long distance at a high voltage, because when we keep the voltage high in the transmission line, we can reduce the heating losses. So the current is low and the voltage is high in the transmission lines. So that's why we use that. So for that we use a useful device which is called transformer. The high voltage, which is like thousands of volts on the transmission line, it is brought down to like 220 volts when it comes to the homes, or in offices and homes we have normal 220 volts coming from our electrical output. So we have to use that fact to solve this question. Then you have question number 12, which is about the relationship wavelength is equal to xd over L, which is the equation for interference, double slit interference. So the light, a monochromatic light, light which has the same wavelength, passes through two slits at the same time, and they are projected on a screen. So you must know what is lambda, what is L, what is X, and what is D. D is the distance between the slits, L is the distance between the slit and the screen, and X is the distance from the center of the screen to the bright or dark fringe, first bright band. Then you have the 13th question, which is about how bright and dark fringes are created on the double slit investigation using monochromatic light. So, bright fringes are created where there is a constructive interference of light waves, and dark fringes are found where there is a destructive interference of light waves. So, this is that what will be asked in that question. Then you have question 14 and 15. They describe, it's about the thin film interference. So, like for example, a soap film or a soap bubble, it can create interference. So, how does it create? So, when the light falls on the bubble, bubble has a thin, is like a very very thin sheet. So it has two surfaces, the outer surface and the inner surface. So when the light reflects from the two surfaces, it can actually interfere with each other when it comes out. When we look at the bubble from some point, it can interfere, and from that you can see the fringes. So that's why we see colors, rainbow colors on a bubble. So that's what is discussed, what will be asked in question 14 and 15. Then the free response question, again, it will ask about questions regarding electromagnetic induction. They could give you a situation in which you have to calculate the induced EMF using the formula BLV sine theta. You should know the angle between the velocity and the magnetic field, and you should try to find the calculate that EMF, and from the EMF you can also calculate the current. So that is using the Ohm's law. Then you have the next question which is asked is about the transformer. So a transformer uses a turns ratio. Okay, so turns ratio is the ratio between the coils, the primary and secondary coils. So they will give you the number of coils in primary and number of coils in secondary, and they will tell you, maybe they can ask you how to find the efficiency of the ideal transformer, or what is the difference between step up and step down transformer. And they can also ask you to find the output voltage, which is the secondary voltage or the secondary current, while giving the number of turns in primary and secondary and the input voltage. So you will use the transformer equation. Then you have the next one, which is determine the type of pole induced on the face of a coil and directed, and the direction of induced current in a coil when a coil and a magnet are in relative motion. So define coherent and incoherent light, bright and dark fringes in double slit interference, recall the concepts of constructive and destructive interference, etc. So these are four different options they have given. So they could ask from one of them or maybe two or three of them. So the first one, again, they will be giving you a case picture, and you have to determine what is the pole which is induced at the face of the coil when the bar magnet is pushed inside the coil or when it's pulled out. So you must be able to describe which direction the magnetic field is produced. Then incoherent and coherent light. That means light, the crest and the trough and trough of the waves of the light, they are in step. So that's coherent light, and incoherent light is when they are not in step. Then you have what is called the bright and dark fringes. So, as I told you before, bright fringes form when there is constructive interference of the light waves. Dark fringes form when there is destructive interference of the light waves. So that's 3 and 4. Then you have what is called the apply the relationship for double slit investigation. So we can use such question. We will put in the values for the knowns and find the unknown quantity. So these are the set of questions which we have discussed. So I hope you will be able to do well during your exam. All the best, and inshallah, all of you will score very high marks. And I will be praying for all of you. Take care and all the best. So this is the discussion on exam coverage. So thank you. All the best.